Hey, what's going on, guys? KIM-1 here. In this video I'd like to demonstrate how the Wave program runs on my KIM-1 emulator, and thankfully to Dominic Bembecca I'm now capable of doing this because he sent me the hex dump for this program, and I've adopted the hex dump a little bit to match the format of byte declaration for the assembler that I'm using here. So if I just grab the code and going back to the emulator and paste it in, and you see like it should be uploaded at the location 200 hexadecimal, so assemble, and you need to make sure that it's indeed 200 hexadecimal. Okay, and then if you go to 0200 and click upload, bytes appear in here. So if you just list the program, you see like this bytes has been loaded successfully, and if you go back to 0200 and hit go, here we go, we got the Wave program running. And now you might be wondering, why am I so excited about this program? And there is a point about this program. So it might serve as a sort of a verification program. So it might verify how proper the emulation of your KIM-1 is actually working. So if you're writing your own emulator, this program is very essential for debugging, because just to give you an idea what may go wrong, so Dominic has tested this program on KIM-1. Here it is, and just listen to him.
You can see it's running quite a bit slower than the Wave program runs, and I'll show you on another one in a second here. Okay, here you go. There's the Wave on the Corsham.
So it's the Corsham KIM clone.
Simultaneously, the Wave running on the Uno. So I think the Uno has problems with displaying because it's emulating. But again, there's the Corsham running Wave. Now I'm going to do a dump of the hex code, and I'm going to upload it to your emulator.
So you see like how this should work. So this is the speed, and
That Wave works on your fantastic emulator. There's Wave.
yeah, thanks Dominic for considering my emulator to be fantastic. Yeah, so here it kind of works, but it's really slow here. And now just a few words on the speed measurement. I believe that's the proper way of calling this thing. So at this stage of the emulator, so this was a couple of days ago, I was thinking that it's running at 1 megahertz frequency, like clock rate of 1 megahertz. But I guess that wasn't really the most accurate way to measure, and I just want to show you the source code to give you an idea why am I thinking like that. So the way how I was calculating this cycles per second, and hence the megahertz, is the following. And well, this formulas quite work in case if we just do this synchronously. However, bear in mind that this is the JavaScript, and in order to avoid kind of web page hanging forever, and just to still to be interactive, so you could have user could have pressed click the buttons and just iterate with the page, like write some assembly code, upload, assemble, upload, doing hex dumps. So this should be working in a background, right? And the way how it's implemented here in particular, let's list how I consider this to be. So we're calling this set timeout and the CPU loop. And it's not recursive call. You might think that this is the recursive call, but I believe that's not the very accurate way of calling this. So if this was like this, then it would be the recursive call, and then it just exhausts the recursive depth quite quickly. But here, without this parenthesis, what it literally does, it calls the CPU loop asynchronously with a delay of 0 milliseconds. However, the actual delay is more than 0 milliseconds. Not sure why exactly, but that's just how things kind of work in JavaScript, to my experience, at least. So yeah, the problem that when it runs this 5,000 cycles, for instance. So initially it was running like 1,000 cycle, and when it was running 1,000 cycles, the speed was around 1 million cycles per second. That was the measurement for this clock rate. However, we need to bear in mind the fact that once we've exhausted these cycles, no matter if this is the 1,000 or 5,000, once we have exhausted that, we have another delay, which is quite significant in terms of there could be really lots of cycles being kind of skipped when we're making this call. So from the user's perspective, you don't really see when this happens. So it's kind of okay from the user's perspective, but from the perspective of the accurate calculation of the actual megahertz, the actual clock rate, this might not be the best ever thing to consider, because it's really laggy here. So I just disable this line printing the clock rate, but what is interesting here is that the way how I try to measure the speed, well, it's a very noob's way of doing things. It's really dumb, just like I am basically. But anyway, here is the trick. So I think that this visual filling of around the same speed should be just good enough. So just to give you an idea, what am I talking about here? So we go back and try to have a look how this works on a Karsham. So here we go. So you see, like, it works like around slightly faster than a second to complete the entire sort of a cycle here, and it's around the same here. Well, maybe here it's a little bit slower, but if I make it slightly faster, it just it doesn't look that pleasing, I would say. So maybe this emulator goes a little bit slower, but yeah, just for comparison. So how? Okay, and on the emulator, well, maybe a little bit slower. Well, also bear in mind the fact that my video recording software is working, so it goes a little bit slower. So without video recording software, it's actually almost as fast as this one. And you can make it even faster. You can make it even faster than it runs on Karsham KIM. It's okay. And if you want to play around with that for various applications, you can always alter this value. So by adding 1,000 to this value, it would be going faster. By subtracting 1,000, it would be slower. So at 1 megahertz, it would be the speed of, as Dominic demonstrates here. So not 1 megahertz. So this is the speed. You see, like, it's slow as hell. So this is the speed if here we set to 1,000, then we'll have this speed. Right, so it's very slow, but with the 5,000s we have this kind of speed, which is I don't know, I think it's quite eye-pleasing enough. So yeah, and also I'm already testing the KIM-Venture game, and with this sort of a speed, the amount of time messages are being displayed on the screen looks very authentic, I would say. So yeah. Okay guys, this is it from my side, so thanks for watching. There would be the link in the description both to the emulator and to this wave program, so you can try it online. Just grab the code, paste it in, assemble, upload, go into address 200 hexadecimal and go, and you got this magnificent wave program. This is it from my side. Thanks for watching. Until next time, and take care.